Okay, so we're going to do the fake Gauss-Jordan on this, and the main reason is because when I write my matrices here, I have 3, 2, and 20, and then 5, 3, and 31. And when I look at my pivot, which is right there, I don't really want to divide by 3 because do you see how you're going to get 2/3 over here? I really don't want to do that, and 20/3 doesn't sound nice to me either. So I'm going to do the fake Gauss-Jordan where I get numbers with zeros, and I don't worry about them if they're ones or not. So what that means is that first row, this guy right there, is my pivot row. And so remember, pivots are permanent, and that's going to be important later too. So just know that this row is permanent for now while we're pivoting on it. We can use it on scratch paper, but we just can't permanently change it. So you want to get a 0 here. So you always use kind of that common denominator or least common multiple. 3 and 5, I can make them both 15s, but you need one to be 15 and one to be a -15 to cancel. So it doesn't matter which one, but just have to decide. So I'm going to make the top row +15, so I'm going to multiply these all by 5. And then I'm going to make the bottom row a -15, so I'm going to multiply these by a -3. And like I said, as long as they add up to 0, so I could have done a -5 on all these and a +3 on all these, it wouldn't matter. So I'm going to go on scratch paper. I have 15, 10, 100. And then over here I have what? -15, -9, and what is that? -93. And these equal 0. If they don't, you messed up. 1 and 7. So I have 0, 1, and 7. Okay. And so now there's zeros above and below. So I'm going to switch over here. So this guy right there is my new pivot. And so that guy is going to become permanent. So I'm going to rewrite it. 0, 1, and 7. And my goal now is to do math with these two to get a 0 above. And so 2 and a -2 cancel. So since this one's already 2, I'm just going to leave it and multiply the bottom row by a -2. Okay. And so the top row is great. I like the 2 there, so that's fine. And I'm going to multiply by a -2. So I get 0, -2, -14. And I'm going to add down. And again, my goal, why is my pen not working in that area? Let's try somewhere here. Okay, so 3, 2, 20, and then 0, -2, -14. I'm just rewriting it because it didn't work over there. So these equal 0, which is your goal, and that's 3, and this is what, 6. So my new row up here is 3, 0, 6. Okay, I'm going to... Well, I think I'll just leave that there. All right, so now I'm going to rewrite it because I have my diagonals with numbers. And so what I want to do now is to get a 1 here. And so to change any number to a 1, you just divide it by itself. So 3 divided by 3, and again, whatever you do to that row, you got to do it to all of it. All right, and I guess I kind of wrote this one a little too quick. I'm just going to erase that because there's really no point to write that twice. So when I divide by 3, I get 1, 0, 2, and I get 0, 1, 7. And so then I can read my answer off because this is your x column and this is your y column. So this x, and I have 1x equals 2. We don't usually write 1x equals 2. We're just like, okay, well, you know, x equals 2. And then this guy is no x's, but it's 1y equals 7, so we know y equals 7. And again, you can go back to your original and sub it into both, make sure it works. So, you know, especially if you don't have a calculator, 6 plus 14 really does equal 20, so that's good. And shove it into this one. What is that? 10 plus 21 really does equal 31, so that's a check. So I know my answer's right. But again, that's how to do the fake Gauss-Jordan pivot. I'm going to show you one other one quick, and so I'm going to pause it for a second, erase all this, and we're going to do one more. Okay, this one I wanted to show you because I would manipulate a couple things before I made my matrices. First of all, this is in the wrong format down here, so I would add 5y to both sides to get 3x plus 5y equals, and that's a 2 there, 52. Okay, so I would manipulate that to get it in the right format. This one I would manipulate to get rid of the fractions. So I would scale everything up by 4 because I don't really want fractions here. So this one I'd scale up by 4 to avoid fractions in my matrices. So that's going to be what? 2x. That's going to be what? Plus 3y equals 32. Just seems a lot easier to mess with than starting out with fractions. And again, it really doesn't matter which one you call row 1, row 2. So that doesn't matter that I wrote it below or on top. So I'm just going to go with my new ones down here. So I have 3, 5, 52, and what? 2, 3, 32. Again, I don't really want to use the real Gauss-Jordan because I don't want to get fractions here. So I'm going to live with my 3. And again, your pivot row is permanent. So just rewrite it. 3, 5, 52. Now, I want to do math with these, but on scratch paper. And so 3 and 2, I can get into a 6 and a -6. Again, the idea is kind of like with fractions. When you added fractions, remember you had to get a common denominator. So it's kind of that same idea. So on scratch paper, I'm just going to multiply the top one by 2. So that's what? 6, 10, and what is that? 104. Right? Nope, I don't even need this on scratch paper. And then the bottom one, I'm going to multiply by what? -3 to get that. Oh, yeah, my pen's having issues. Okay. And again, I'm multiplying. So that one's what? -6 and -9. And again, we're multiplying here. And then what's that? -96, I think. All right, so when I add, these equal 0, this equals 1, and this won't always equal 1. We're just kind of lucking out here a little bit today. And that's what? 8. So 0, 1, 8. Okay, so now that I have my zeros above and below, which are not 2 by 3, you know, is just one pivot. Now my permanent row or pivot's going to be there. And it's nice that it's a 1, but it doesn't have to be a 1. You can live with whatever you get. But remember, this is my new pivot row. And so this row is permanent. So now what we're going to do is we have to get a 0 between these guys. So it's nice that it's a 1. That's why the real guys actually made you get a 1, but it doesn't have to be 1. So with 5 and 1, I can use 5 and a -5. So I am going to leave the top row alone because I actually kind of like the numbers in it. And then the bottom row, I'm going to multiply by what? -5. So I get what? 0, -5, and what? -40. Okay, so when I add, I get what? 3, 0, and what is that? 12. So up here I'm going to get 3, 0, and 12. And again, you're not done because we want to get 1s at the end. So in this method, you just wait till you're all done to get the 1s. So this one's already a 1, which is great. I'm just going to, these pens are kind of acting up. I'm going to divide by 3 to make it a 1. So I get 1, 0, 4. And then down here I get 0, 1, 8. And then I still end up with my 1s on my diagonal and so forth. So this is your x column, this is your y. So you have 1x, no y, so x has to equal 4. And then my y, I have 0 x's, 1 y, and that's just a 1. So my y equals 8. Okay. Now again, let me try a different pen, see if that's kind of frozen, but there we go. All right, so you can check up here to see in your original if it works. Half of 4 is what? 2. 3/4 of y would be 6. Yep, that really does equal 8 when I add. And then the second equation was 3x, which is what? 12 equals, shoot, what was that? Was that 52? And then minus 40, which 52 minus 40 really does equal 12. So I can kind of check my answers and be like, yep, I know this guy's really correct. And again, marker's acting up. But, so I know the answer to this from this matrix right here is that x really does equal 4 and y really does equal 8. And I've checked my answer. I did my pivots. I should be good to go. All right, hopefully that helps you with the fake Gauss-Jordan. If you want a video on the real Gauss-Jordan, just let me know.